Okay, so in this video clip, I'm just going to take you through how we uploaded the Financial Times data set covering the period 2007-2015, and that was related to bank fines. So if I go into the link here, the link is a legacy URL. And if I come down to, now I've discussed this before in the previous video clip, the CSV file, and it will download into my downloads. And if I want to bring that across so that I can read into the Google Colab using the Pandas command. Now, again, the Colab can be set up in a way that the cells can be highly edited. So you can, using Markdown format, and write in, reasonably high quality description of what's going on in your report. So again, Colab is based on Jupyter Notebook technology, and that allows you to weave in a lot of description and a content based on just describing your output and being able to narrate your results. Can be very powerful when combined in with data transformation. So we're going to upload, we've downloaded the data from the Financial Times. I want to upload that same data. Now, how do you find that file? You come to the folder icon here, come across to the content folder and upload. Then you go look for the latest download. Here is data 4. So I've downloaded the Financial Times data set a few times, and I want to read it directly in, and the code cell relating to that is here. So if I run this command, it won't work because I don't have the right file name. We can either change here or over here. It might be easier just to make the change here. So we'll rename this file and just remove the 4 and parentheses. Rerunning the Pandas command again. You can see the data has come across, and if we want to eyeball that data, it's all available here. Right, so that actually is quite powerful. If we wanted to take a look at the original file itself, could go into the downloads and just look at that data for CSV file, and it should come up here in Excel. And again, we have the date, the name of the bank being fined, the regulator, the Department of Justice, Fannie Mae, the reason for the fine. That's one of 7, right? So there's 7 different categories that were set up by the Financial Times. The amount of the fine, okay, so in value in millions, so this is 16 billion thousand, so 16,650 is 16 billion, $650 million. It's a staggering figure. A description, and then there was the originally, but now defunct, a URL to the FTSE column or story, and that's no longer there. So when we observe that final column here, you'll see nothing is coming up. There's nothing there. Okay, so if we want to read in the data, we created the object. Now I'll leave a link below to a tutorial on Pandas. So if this is new, no problem. I'll put in the description below the video some tuition that you can access just to go through. Some people might be familiar. What Pandas allows us to do here is bring in data, manipulate data, filter the data, do many of the things that we do in Excel, in fact, but a little bit more. and then do it for much larger data sets. Excel is sort of limited in terms of what you eyeball on the screen. The Excel is sort of set up that you can eyeball the data and maybe get a more textual or tactile feel, whereas the Pandas is at a sort of higher level of abstraction and allows you to automate much bigger data sets, and data sets increasingly are getting bigger. Okay, so we brought in our data and just basic things like, okay, what's in our data set? There's 250 rows, there's 7 columns. So there was 250 finds recorded, and there was 7 columns of data. So 7 attributes, if you like, or 7 columns. And if you wanted to, what were the data columns? Well, it was date, bank, regulator, reason, value, millions, description. And then the final column, which is sort of empty, an empty shell, the FTSE story, URL. Unique number of unique instances. So there was 156 states. There was 61 banks. There's 30 regulators. There was 7 reasons. So the FTSE categorized fines into 7 different categories, right? And then the value in millions, so 185 billion. Description, 179 description. So 185 different, not 185 billion, 185 different amounts, unique amounts. The description 179, so some duplication, some repeats, and then they're basically, this was just empty, right? Okay, if we want to get descriptive statistics, the descriptive statistics for the would only apply to the numerical value. So we're looking at, there was 250 million, sorry, 250 fines applied. The average fine was 644, so 644 million was the average for the fines that we're looking at. The standard deviation, 851 million. The minimum fine that we have in this data set was 1 million. The maximum fine was that one to Bank of America for 16 billion. Unique bank, 61. Unique regulators, 30. And if we want to get a printout of the different regulators using the Pandas command, we could automate that just to get a list of who are the regulators in our data set. So the Department of Justice, Department of Housing, Urban Development, and Fannie Mae. Now that would be quite useful for a researcher, for a journalist, for maybe an accountant who is trying to put together some kind of semblance of explaining to somebody new to the data set, okay, who are the main actors here? Being able to pull off from a column the unique instances of each regulator and print out and go through, very, very useful. In Excel, that might take a little bit more reworking, but if you're working with a data set or a database where the attributes and the columns are set up in a way that are maintained and there's certain protocols that apply to the database, then having Pandas commands that read out in a prefixed way the retrieve information relating to the banks or to the regulators or to the types of fines and so on, that can be very useful. Again, the Colab allows us to describe you both have text cells and code cells, and the text cells can be highly formatted. And if you want to write a report, if again you're trying to explain to colleagues who are the main regulators, easy to weave that into the Colab. So the Colab is Jupyter Notebook technology, and it allows you to combine into a report. Let's say if you're producing a report, you could provide the report in the form of a Jupyter Notebook, and that gives you quite a bit of control. So if you're working in a team and you're building a report, You could share in a collaborative way with colleagues the information. So you could restrict it or anyone with the link. And then you could also, if it's anyone with the link, you can give them different status. So viewer, or you can make a colleague an editor. And then if you copy the link, then when you share it, you allow maybe a team to work on the Colab interactively. Okay, so we might want to know who are the different banks involved here. We've JP Morgan Chase, we've Wells Fargo, and there's 61 banks in the list. Some banks are foreign banks. They're headquartered outside of the US, and other banks like JP Morgan, Bank of America, Wells Fargo, headquartered inside America. Also, if we wanted to bring in data, if let's say we're looking at these banks and we wanted to get a sense, who are the big banks? And do we have a way, is there a hierarchy, or is there a list of which banks are biggest by market cap, or by maybe the size of their balance sheet or their profits? We might be able to find an external source. So rather than copy and paste into report a list, it may be possible that you could retrieve from a portal, from a web address. You might be familiar with a URL. So Wikipedia generally is quite reliable. So if I want to maybe find some independent source that's reasonably well curated, let's just go back. List of largest banks. So it's this portal. And you see here we have a list of the biggest banks. And it's the top 100 banks. And they're ranked in terms of assets. And in terms of market cap, JP Morgan, Bank of America, biggest. Wells Fargo, HSBC, Morgan Stanley, in terms of total assets. A similar type of ordering. Goldman Sachs, Morgan Stanley, US Bancorp, so on. Now, if we want to import that table and the data directly into Colab, we can use a library called requests and Beautiful Soup, and then do the data manipulation using Pandas. So I won't go through all the detail here, but you can see the data contained in the table has been brought across. And we've created this object where we can read directly. Likewise, if there was another source, let's say we wanted to get this data from the Federal Reserve and get some kind of ordering, which banks are biggest, we could copy maybe a URL. So again, the Federal Reserve is a very credible source of data. And we could take a look there at the large commercial banks. And you have JP Morgan, Bank of America. Now the ordering here is a little bit different, if I remember correctly. And it's consolidated assets. And there's actually more columns and rows here. If we download the PDF or the ASCII file, we can see that this is just, we don't have the full, what's visualized here. The data set is actually much more substantial. Okay, so if we want to bring this data in from the Federal Reserve website using the web address, the URL, and then that data fed, if we were to, maybe it's not wise. Okay, if I put in data fed, that object that's created, it will be set up in a way that's not really that human friendly. So to make it a little bit more readable, we might convert it into a Pandas data frame. And then when we eyeball the data, now there's quite a bit of data in there. It's more than what was presented there in terms of the visualization, in terms of the presentation here, right? But when we go back in, you can see, there's quite a lot of data. So we might, using Pandas command, say, look, let's get the first 6 columns and get the first 10 rows of data rather than all of the data, right? And that might make it a little bit more human friendly and readable. So if we look at the first 10 banks here, JP Morgan, Bank of America, Citigroup, Wells Fargo, might be Bancorp, PNC, Trust, BK, and then Goldman Sachs. Okay. Okay, so it's kind of we're looking at the bank fines. And again, if we're coming to this for the first time, we might like to get a sense of how significant are the fines, and are the fines applied on the biggest banks? Is there a kind of proportionate regime that as the bank is bigger in terms of its balance sheet, in terms of its profits, that the fine is scaled? And again, if we look at the from the violation tracker, which is the more current, right? If we take a look at our list of top 10 fines, again, I extracted this one. It's more current. It's 2023 as of August 16th. The cumulative fines applied to Bank of America was 87 billion, JP Morgan 39 billion, UBS 29. So there is some semblance that the list we observe here is aligned to the size of the banks. So banks get fined, but the fine is set up in a way that is crafted that the biggest banks tend to get the biggest fines. And I guess that's just logical. Okay. Now, in addition to looking at the size of the fines, we might be interested in looking at, what was the stock price behavior. So if we wanted to get a time series, we're looking at the largest banks here, JP Morgan, Bank of America, Citibank, so on. If we wanted to take in the Wikipedia list and say, okay, let's take a look at the stock price behavior over the period 2000 to 2023, one very nice source for getting stock price data is Yahoo Finance. So if I go in directly and take a look at Yahoo Finance, Bank of America, a free source for time series data is Yahoo. And they have a lot of data on options. The financial data. So the financial data is the balance sheet, income statement, cash flow. And all that's provided for free. And then you have the historical data. And the defaults here would be maybe go back 1 year and its daily prices. Now you can manipulate the Yahoo Finance to go back, for the entire period, maximum could be going back 40, maybe 50 years, apply. See the dividends. Okay, so if we wanted to automate the extraction of this price data from Yahoo, now we can download the data directly in a manual sense, so we could, do the download and so on. But with Pandas and with the yfinance package, we could automate this in such a way that if I load in the yfinance package, now we're going to take a look at 2 libraries here, yfinance and yahooFinancials. Would appear here all the installation here is everything is satisfied, so it's fine. And I'm going to go based on the Wikipedia list and download. I want to download the Bank of America price data, Citigroup stock price data, Goldman Sachs price data, JP Morgan, and Wells Fargo. Again, I'm following the lists from Wikipedia, the largest banks in the US. And to load in those banks, I just take the stock ticker. GS is Goldman Sachs, JP Morgan Stanley, JP Morgan Chase, WFC, Wells Fargo. So I load those in. I set the dates. So from 2003 to 2023, and I'm going from July to July. And then I want to run using the Plotly library, a visualization. So I want to download the data directly for all 5 stocks. And I'm doing it, taking a weekly data. So the observation, the interval is weekly. And I'm not going with the OHLLC data. I'm going with just the adjusted close. And then I want to view all 5 stocks, the time series for the period 2003 to 2023. And generally I use Matplotlib, but here I'm using Plotly because I want to have a graph that's interactive. So again, if we were to do this manually, it would take quite a bit of time, but these 9, 10, 11 lines of code allow us to download the data and then set it up as a table, set it up as a visualization. And we can see here the performance of the different stocks over the period. Citigroup was flying high, took a very nasty hit during the financial crisis, and its stock price hasn't recovered to the same extent as, let's say, when we look here at our green, which is Goldman Sachs. Their stock price, just shut up, and has done very well despite being fined as well, despite the different mishaps associated with Goldman Sachs. They have managed to perform very credibly. The other bank that has sort of done extremely well is JP Morgan over the period. Now, we can't maybe judge. I mean, this is one way of gauging the performance, but a much better way would be to look at the cumulative returns. But before I get there, it might be useful also the stock data that we have, that object that I created, that object is taken here using Plotly to produce this graph. And if we wanted to eyeball maybe the data for the stock data, okay, if we run stock data, it brings up the data set that we have here. So there is Bank of America, Citigroup, Goldman Sachs, JP Morgan, Wells Fargo, going from the period 2003 up to 2023. And there's 1,045 rows, 5 columns. Okay, so that there is an object. We have the weekly data over the period. Okay, if we want to judge maybe the actual performance, compare like against like, this may not be completely convivial. It might be the most efficient way of achieving that. So cumulative returns and rebasing to 2003. So if I run that command again, but I say, let's produce a graph that gets the cumulative returns, and then look at the performance of each of the 5 top banks in the US over the same period. You can see here Citigroup. So we rebase everything to 2003. They all start from the same base, and then look at the performance of the banks over the period. And what's striking here is while Goldman here looks to be the top performer, when we measure it in terms of cumulative returns, it seems to be clear that JP Morgan emerges as the winner. and Goldman Sachs as second in the list here, and then further down, Wells Fargo, Bank of America, and because the graph is interactive, the variable BAC is Bank of America, Wells Fargo, and the one that seems to perform most, really very weak level of return cumulatively is Citigroup over the period. Okay, now if we're trying to make a connection here between the fines and the performance of the banks, it would appear if I go back to, let's go back to our, okay, so automating the stock price data. If I go back to the violation tracker, we can see here there's quite a divergence between the amount of fines imposed on JP Morgan and Bank of America. Likewise, quite an amount of fines applied in Citigroup, and then much less fines applied in Goldman Sachs. So in some respects, one has to wonder, now the size of the fines are colossal, and they're colossal even when we compare it to the TARP money, 45 billion here, Citigroup, Bank of America, 45 billion, AIG, JP Morgan, Wells Fargo. The TARP support provided is dwarfed by the size of the fines. And I mean, it's not beyond our comprehension then when we look at we come down to here, yfinance, that the fines are having some kind of impact, right? So over a longer period, if banks are fined very heavily, it tends to suggest that the bank's performance is not as strong. Now, there's two ways of looking at this. One is if you're getting a lot of fines, it's largely because you're not adhering to the rules. It suggests that there's something fundamentally wrong. So Bank of America took huge amounts of fines. Sometimes some of the fines that Bank of America took on board were fines that were applied to banks it had taken over. So there were sort of legacy issues that applied to banks that they absorbed in because of consolidation. And the fines relate to the corporate governance of other entities that Bank of America happened to, so that in a sense, they may have picked up a poisoned chalice here and there during their life. And the fines then that were applied in those institutions, even though there were legacy issues, applied to Bank of America. But the size of the fines, in all likelihood, do have impacts on the level of profitability, the amount of capital available to each of these institutions, and the ability for each of these institutions to grow. And the two institutions that stand out here as doing best in terms of performance, JP Morgan and Goldman, are also institutions that took less fines, relatively speaking. Okay, so that's a form of that's an insight. Just different ways of reading it. It might be one sense that the agencies, as they work, the regulators, in some respects, they're picking the winners and losers. But also, it must be said that the regulators, when they apply fines, they're applying fines based on the behavior of banks. And if there are corporate governance issues, if there's abuses and scandals within the banks, then the fines are going to be much heavier. So in some respects, the size of the fine relates also to the behavior and to what's going on in these institutions. And if you have really egregious forms of abuse within institutions, then that tends to set the tone and may put the bank on a certain path in terms of its growth capability. Okay. If we want to take a look maybe at the balance sheets of banks, I'm going to take a look at the balance sheet of Bank of America. We can also use yahooFinance. And then the data remember, if we go to the financials here for Bank of America, there is, that's the income statement, balance sheet. We have for 2022, 21, 20, and 2019, the balance sheet of Bank of America. If we wanted to bring this directly into our Colab, automate the extraction of that data, again with Yahoo Finance, we can run that report and we get those dates. Likewise, if we were, let's try that again. Okay, so we could get the profit income statement, the cash flow, and the balance sheet. And if another package that I like is yahooFinancials. You might read through this yourself. I'll share this Colab beneath the video. I'll do a pip install. Again, it's another Python library that can be used to automate the extraction and analysis of data. Again, we're pulling the data in through Yahoo Finance API, and we can bring in again the balance sheet, like what we did with yfinance. And if we wanted to apply some type of ratio analysis, we could run, a total debt, current ratio, the equity multiplier, long-term debt ratio, and using Pandas command, set up those ratios so that when we run, we automate the estimate of the total debt, estimate the current ratio, the debt to equity ratio, the equity multiplier, the long-term debt ratio, and then provide some analysis of that. Again, it's very generic, so I won't go too deep, but it's fairly standard type analysis of those ratios. Okay, now that's very powerful because it means if you have balance sheet data, income statement data, cash flow data, and you want to produce these ratios, once you set out the formulas and are happy that the formulas are consistent with the standard analysis, then you can automate that and produce a report. What we have here, of course, is a text box, text cell, applying some type of analysis, but the output cell is being driven here by the ratios that we set up in order to calculate the magnitudes of those financial ratios. Okay, now that's probably, if we want to do some analysis of the profits, again, there's a Wikipedia, and I might just set that up in the next video clip. So I'll pause here.